This is a two-part video series that's going to help users of aPriori and CAD systems to achieve best modeling practices and also best rounding strategies. A little more detail on the modeling practices. We'll look at offset surfaces and when to use them and when not to, and that's more for pocket floors and lofted surfaces. Helical sweeps versus cosmetic threads, solid text versus cosmetic text, and then excessive chamfering on parts. And then for rounding strategies, we're going to look at some of the best ways to round parts, and when you go through the aPriori menus, which is going to show you what looks good and which doesn't look so good. And we'll look at big walls on the rounds versus small floors, putting the rounds on last, walls first, floors second, and then avoid walls and floors in a single feature. So there's a few things that we'll review. So to begin, we'll start in aPriori. We're now in aPriori, and we're going to review best modeling practices. So I've got a part named Bad Modeling Practices and a part named Good Modeling Practices. A couple things we'll take note of before we go into the CAD system. The cost is $781 on this one, and then on the other one, the cost is $389. And these are unconfigured VPEs, but by achieving better modeling practices, you're going to get a more accurate quote on your part. A couple other things to note here are the number of surfaces. We have 226 planar surfaces, is quite a few, a lot less on the other part. And then we'll go into the design to cost menus. We want to notice there's 134 features to review here. And then something else to notice is finish mill op type. Here we've got facing, side milling, contouring, general mill finish. So you typically on really good parts, you want to see everything in face mill and side mill, although sometimes you do have to contour. If we go over and look at the best modeling practices, look at the surface counts, it's considerably less. Also, if we go in and look at features to review, we're going to see that we have only 2 features to review. And that's just saying this guy, because it's obstructed and you got to ball mill it, and that's a curved surface on the bottom, so you got to ball mill that as well. And then we're going to go look at finish mill op type. Here you can see that most everything is in face milling and side milling, and that's where you want to be for an optimum design part in machining and get the lowest cost part. So we'll jump over to the CAD on the bad modeling practices part, and we'll take a look at some of this stuff. First is the floors, and I've got something called bad floors. The reason it's called bad floors is if we zoom in on this, I've got a loft surface or a curved surface out here. And when I went to do the pocket floors, I simply offset the surface. I mean, that's fine. It gets you a quick model. But if we go back to the CAD file, what you'll notice is those surfaces are all contoured, meaning ball milled. So they take quite a bit longer to do. If we go in and look at the good modeling practices part, and I look at the technique for those surfaces, you can see this one here, because it's obstructed, is ball milled. But all these other guys are face milled. And that's what you're seeing right here. Optimally, that's what you want. And the way you achieve that is by, instead of just using that loft surface, it takes a little more work in CAD, but you've got to create a flat plane on the bottom. And all that was an extrude. Granted, it adds a little more weight, and if you want to take the time to do it, you can offset this surface and do each of these as separate features, but ultimately it's going to pay out in the end, because it's going to take a lot less time to machine those surfaces. So the next thing is bad text. Well, I call it bad text. This is solid text. It looks pretty cool in the solid model, but it has all kinds of negative implications when you go into aPriori and when you try to machine it, because you really can't machine it. This isn't good for nothing more than a picture on the drawing. If we come over and look at this part, here we've got something called good text right there. That's just a text feature, but with this, when I go to NC Program It, I can actually pick that feature and drive that geometry. With the other geometry, I can't do much. And then if we go back to that aPriori, you can see there's the bad text. This is adding to quite a few of your features to review. Again, it's because it's non-machinable geometry. So if you just go ahead and use cosmetic text, that works quite a bit better. And then this jacks the surface count way up. And when you have a higher surface count, that means it's going to take a lot longer to process this model. If you have solid text all over the part, it's going to get really high in feature count, and these parts will take a lot longer to cost, and you're not going to get much from it. And then we'll go in and look at what I call bad hole here. This is a hole that was defined as just a cut in the part, and that's what we see here. And then what I did was a helical sweep to represent the thread. And although once again it looks cool, it's not going to do too much for me when it comes to programming it or even on the detailed drawing. So if you could avoid helical sweeps and instead use the hole feature. So if we go back to our good part, you can see here I've used the hole feature to define this, and then I also get my note for the drawing. And then when you get into aPriori, the implications are on the bad part. We go to look at that simple hole. You can see that I've got a center drill and a drill that was automatically tied to that thing. And then I've got that helical sweep there. Once again, if we go to features to review, this is highlighting as sharp corners because aPriori really doesn't know what to do with it. Whereas if we look in the good modeling part, we don't have the features to review. And then if we go in and look at that hole, it's got the hole picked up, center drill, and it also found the tap or the helical thread that you're going to put on that thing, or the thread mill. So you get a lot more from that cosmetic text that was put in the model. And then finally, the last thing that we did in this was chamfers and rounds. And this, I see it a lot on parts, is somebody goes in and puts excessive chamfers on a part to represent an edge break. And there's really no reason to do that, because when you're driving this geometry as an NC programmer, you want the true edge. You really don't want one of these offset edges. So if it is something that can be done on a burr bench or with a deburr tool, typically you don't want to put that in and just put a note on the drawing to break the edge or to round the edge. If it's a much larger chamfer, then go ahead and put that in. And it's kind of subjective as to what's a larger and smaller chamfer. And once again, the implication of putting that geometry in there is you're going to get a much higher feature count here with all these little tiny edges. And then what those edges do is degrade other surfaces in the model. And this is a perfect example of that. You've now got sharp corners driving into these faces, which say that you can't side mill them, and it's saying you got a sharp corner, and it's saying it's problematic. So those are just a few pointers on things you do. The next video is going to be on rounding strategies. Thank you.